Hello everyone, welcome back to Math Specs. My name is Stephanie, and today we're going to continue with our absolute value practice set. Today's lecture is accompanied by student notes, and you can find those in the description in a PDF format. You're welcome to download those and follow along with the lecture if you'd like. So let's get started. So for the first problem, we're asked to find the opposites of these numbers. And if you remember, now would be a good time for you to either reference the previous lecture and maybe off to the side, write down the definition of opposites. And remember, opposites describe two numbers that are equally distanced from zero and they are on different sides of zero. So for 1, the opposite of 1 is going to be -1. For B, the opposite of -3 is going to be +3. For C, the opposite of -5.75 is going to be +5.75. And for D, the opposite of 0.5 is going to be -0.5. So these are opposites because they are two numbers. So let's go ahead and write the definition off to the side. Two numbers, it describes two numbers that are the same distance from zero on the number line, from zero, and they are on different sides of zero. So what are the two sides of zero on the number line? So if we have a number line here, we have 0 in the middle, of course. So for A, we have +1 and -1. So we would graph +1 right here, and -1 would be on the left side of 0, and +1 would be to the right. So these are two numbers. They are the same distance from 0. This is one step or one unit. From -1 to 0 is 1, and from 1 to 0 is also 1. So they are the same distance from 0, and they are also on different sides of 0. So -1 is on the left side of 0, and +1 is on the right side of 0. So this satisfies our definition of opposites, and so do all of the other examples. So hopefully you are understanding this, and if you have any questions, go ahead and leave those in the comments down below. But for now, let's continue to the next example. Here, we're asked to evaluate the expressions and take the absolute values of these numbers. So again, I encourage you to go ahead and revisit some of the past lectures and write the definition of absolute value. Okay. So for A, if we take the absolute value of -12, we're going to take the opposite of -12. So we're going to multiply that by a -1. This will give us +12. And for B, we have the absolute value of +6. So this will give us +6. For C, we have a negative times the absolute value of 5. So the absolute value of 5, +5, is going to be +5. But because we have a -1 out here, we're going to multiply it. So what is -1 times 5 is going to give us a negative. So you can go ahead and also list all of the properties that we also discussed. In the previous lecture, where we discussed the absolute value of numbers that are negative on the inside, it's going to be the opposite of this number, so it'll be positive. We also discussed the property of the absolute value of 0 is going to be 0. And we also discussed the very important criteria that absolute values are never negative. Okay, so go ahead and write the definition of the absolute value and list all of the absolute value properties on this paper as well. So you can draw a line here and list the properties as well as the definition of absolute value so that you can sort of see the properties next to the examples on the left. So let's go ahead and continue to the next example. So here we're asked to find the opposite of positive 5. So like we said, the opposite of a number is going to be the same distance from 0, and it will be on the opposite side, on the different side of 0. So first I'm going to graph 5, and it's going to be here to the right of 0, because remember our number line has two sides. We have a positive side to the right and a negative side to the left. So 5 is going to be on the right hand side, and it'll be right here. And 5 from 0, this from here to here, is 5 units away. So my other number will be on the left-hand side of 0, because remember it has to be on the other side of 0. So if 5 is on this side, then the opposite of 5 has to be on the left-hand side, and it has to be the same distance from 0. So from here to here, it will also be 5 units. You could also count 1, 2, 3, 4, 5. So the opposite of 5 is going to be negative 5. So you can write the opposite of 5 is negative 5. Okay? And I always encourage you to write down the definitions of words to really test your comprehension. Maybe you can try to write them from memory, and if you can compare that to the actual definition, that would actually be really helpful, because you get to test your comprehension and see what things you maybe need to make flashcards for. So let's go ahead and continue. And here we're asked to find the solution of the absolute value of x is equal to 17. So what are we asked to find here? We're being asked to find x. What is this number? Or is there more than one number? So let's go ahead and write that. So in this problem, we are asked to find values for x. Okay, let's actually erase that. Okay, so we have to think of the absolute value of the definition of the absolute value, which is the distance from 0. So we have a number line, and we have to think, what values can we insert into our absolute value that will give us positive 17? So what two numbers on the number line? It will be negative 17 as well as positive 17, right? Because these two values are the same distance from 0. So from negative 17 to 0, we will be 17 units away, or 17 jumps. And from 0 to positive 17, we will also be 17 units, or 17 jumps away. So for example, if I chose negative 17 and I plugged it into my absolute value for x, and if I took this absolute value, I would take the opposite of negative 17, so that means I would multiply it by a negative 1. Negative 1 times negative 17 is going to give me positive 17, because if you remember, a negative times a negative will give me a positive. So that works. And if I plug in positive 17 into my absolute value for x, when we take the absolute value of positive 17, we will get 17. So the solutions for this, so The possible solutions are, we can write 4x. It's always good for x to write a conclusion or to write a statement that answers the question. The possible solutions for x are negative 17 and you can say positive 17. Okay. It's always good to write a kind of concluding statement and to be able to put your answers into words. Usually it may seem easier to just say, negative 17 and 17, x can equal that. But there's a lot for you to gain from being able to write this out and be able to explain your answer in words, because the more practice you have with this, with being able to write down your, a statement for your answer, the more you'll be able to see if you are having comprehension issues, and if you're maybe not understanding what the problem is asking for. So these are really good ways for you to demonstrate your understanding and to also get help if you're confused, okay? So we're going to continue to the next slide. And here we're asked to graph -2 and -6 on the number line and compare the numbers. So if you remember, when we graph our integers, we just go on the number line, find the number, and put a dot. So for -2, it's negative, so it's going to be on the left-hand side of 0. So here it is, -2, it's 2 units away from 0. And -6, because it's also negative, will also be on the left-hand side of 0, and it will be 6 units away. And you could always count it. You could always, jump there, 4, 5, 6, and there it is. You can go ahead and erase this. So now we're asked to compare them. So which number is bigger, which one is smaller? And so I'm going to compare -6 to -2. You could also compare -2 to -6, or you can just, switch the inequality, whichever is easier for you. So -6 to -2. If I go to -2 right here, I'm standing right here, and I look towards -6, I'm going to be looking towards the left of the number line. So that means that -6 is going to be less than -2. Because remember, we had, this would be a good time for you to go and review our graphing and comparison rules that we have for integers. So if a number is to the left, then that means that it's less than. And if we are looking towards the right, then that means it's greater than. And so here, if we compare -2 to -6, we could just write the other inequality. So we could just switch this less than to a greater than. But for comprehension, we're going to compare it. So if I go stand here in -6 and I look towards -2, I'm looking towards the right, in the right direction. So that means that -2 is greater than -6. Okay, and also as our integers get closer and closer to 0, then their values become much bigger. And that's something that you just sort of gain an understanding of as you do more examples and you have more experience with negative numbers. In my experience, students have a much easier time using these comparison rules of left and right with positive numbers, because we know that, for example, if we were to compare 5 to 7, we know that 5 is less than 7. But if we wanted to use sort of our comparison here, if I was to stand at 7 here and look towards 5, I'd be looking in the left direction, right? I'm going this way, so it would be less than. So definitely keep doing more examples with negative numbers and comparing negative numbers to one another. I think that that's a great way for you to become comfortable and also compare negative numbers to positive numbers, and being comfortable with using the two sides of 0 on the number line. So let's go ahead and continue to the next example. And that concludes our practice set for absolute values. I hope that the notes provided were helpful and that you were able to maybe fill in some definitions of absolute values, or for opposites. I always encourage you to actively review your notes and to constantly edit and go back. So I hope that this set was helpful. Next time we will be discussing adding real numbers. So we will be doing things like -3 plus 2, -6 plus -2, things like that. So I hope that you can join me for that. I really appreciate your time and attention, and I hope to see you next time.